Hi, hello all. Let us talk about aldol reaction. So in aldol reaction, a molecule of aldehyde reacts with another molecule of aldehyde in presence of a base or an acid to give a product like this. This product is called aldol because it has an aldehyde part or and an alcohol part. So this is called an aldol and the whole reaction is called aldol reaction. In aldol reaction, this aldehyde or this starting material need not be an aldehyde. It could be a ketone. And then the product will be like this. Still the molecule is called, the product is called aldol and the reaction is called aldol reaction. And this could be the second molecule of aldehyde. This could also be a ketone, and then the product will be this one. And this is also an aldol, and the reaction is aldol reaction. Okay. Notice that the main new bond is shown in red, and it is a carbon-carbon bond, CC bond. So this aldol reaction is an important reaction. So let's see the mechanism. So for the mechanism, let's start with the ketone. This ketone is reacting with the base. Let it be an OH minus. So OH minus is a base, and a base will pick up a proton. Which proton? There are 6 protons in this ketone, and all the 6 protons are equivalent, and they are acidic to a certain extent. As you know, this is a CH3, and this one is also a CH3. So there are 6 protons. Let me write it as CH3 itself, CH3, and let me write one hydrogen separately like this. So autocorrection is there. This is CH3. Still this one is CH3, and this OH minus will pick up this proton, or for any other protons. In this case, all these protons are equivalent. All these hydrogens are equivalent. So let's show it with the curved arrow mechanism. Let us show that with the curved arrow. Okay. So what does this mean? This means the 2 electrons in this oxygen is going to stay in between this hydrogen and oxygen. Or in other words, the maximum probability of finding these 2 electrons is going to be in between this hydrogen and this oxygen. Or in other words, there is going to be a new bond between this oxygen and this hydrogen. While this new bond is forming, an old bond will break, and this carbon-hydrogen bond will break. Let us show with the curved arrow. Let us indicate that with the curved arrow. Okay. The 2 electrons in this bond is going to stay on this carbon. So let us copy it down and try to make sense of what happened. So, okay, let me remove these arrows, and this means the 2 electron is going to be staying between these 2 atoms. That means oxygen and hydrogen. So there is going to be a new bond. That is this one. This auto correction is this, so bear with me. So that's the new bond, and old bond is breaking. So now this is an auto correction because it's CH3. It is showing as CH3 because of auto correction as chemistry software. So actually this is CH2. As you know, this is CH2, and one hydrogen is removed. So that CH2 is there, and CH2 will have a negative charge. Why this negative charge? We can imagine in this way, the 2 electrons in this bond, 1 electron belong to hydrogen and 1 electron belong to carbon. Now in this case, both electrons are going to carbon. So carbon got an extra electron. Carbon got hydrogen's electrons too. So carbon got an extra electron, so it will have a negative charge because it was neutral. So it got a neutral species got an extra electron, so it will have a negative charge. And by understanding mechanisms or reaction, how the reaction progress in this way, we can predict product, we can predict intermediate, etc., etc. So it works for us. Now we have a negatively charged species. Let us consider this molecule or this anion. This is a carbanion. Let's copy it down. This carbanion has a resonance structure. This is the resonance structure of the carbanion, of this carbanion. And now that's why this hydrogen is acidic, because the carbanion has a resonance structure or resonance stabilized, and because of this, because as this species is stabilized, this compound is relatively acidic, and a base can pick up a proton from this molecule. We can safely say this one is more contributing to the resonance hybrid. This species will be called as enol because this is alkene, so ene, and this is alcohol, so ol. So combining, it is an enol. So the negatively charged version of this enol is called enolate. So the resonance structure, this one is called enolate. Okay, so enolate, we can safely say enolate is more contributing to the resonance hybrid, as the negative charge is on oxygen, which is more electronegative. Okay, so we have a negative center, and this could attack a positive center. An aldehyde or ketone acts as the positive center in this Aldol reaction. So let us consider an aldehyde which acts as the positive center and the second molecule in this reaction. So what could be the mechanism? What does this mean? This means the two electrons on this oxygen is going to stay in between this oxygen and this carbon. Or in other words, the maximum probability of finding these two electrons is going to be in between this carbon and this oxygen, or in other words, there is going to be a new bond between this oxygen and this carbon. And this old bond will break. It will break, and the two electrons in this bond will make another bond. The sigma bond between CH2 and this carbonyl carbon, aldehyde's carbon. So this is going to be the new bond. This is going to be the new carbon-carbon bond. And when the new bond forms, an old bond will break, and that will be this oxygen-carbon double bond or the pi bond, and this will break, and the two electrons will go to oxygen. So this is going to be a new bond. So let's write it this fashion, and this negative charge is no longer there, and this bond is breaking and is forming in a new bond here. So this is auto correction, bear with me. Now this is the new bond, right? And old bond is breaking here, and that will be O minus. So okay, so this is the new bond. Let's make it in a red color. Okay, let us make it a little more, say, beautiful. Okay, so we have a new bond, new carbon-carbon bond. Now we could go with protonation. A water molecule will provide the proton, so protonation will lead to our product. So let us go over this reaction once again. In Aldol reaction, an aldehyde or ketone reacts with another molecule of aldehyde or ketone in presence of a base or an acid to form a product known as aldol. Now the mechanism starts with the deprotonation of the ketone or an aldehyde or ketone which has an alpha hydrogen. This is known as the alpha hydrogen, which is next to the ketone or the functional group, the ketone or aldehyde, C double bond O, is known as the alpha hydrogen. This is alpha carbon, and hydrogens attached to alpha carbon is known as alpha hydrogens. So one of the alpha hydrogens will be picked up by the base, and it will lead to a carbanion. This carbanion is resonance stabilized. And this stabilization of this, or the stability of this product, is the reason for the acidity of this ketone or aldehyde. So ketone pK is around 25, while the acidity of aldehyde is around 20. Now it's not that acidic, but still it's acidic enough, to create an equilibrium with OH minus or any suitable base to form this carbanion or this enolate. So this carbanion has this resonance structure, and this resonance structure is called enolate ion. So this enolate ion, this is the negatively charged species, attacks the positive center or this carbonyl carbon atom and forms a new carbon-carbon bond. During this process, C double bond O forms again, and also this C double bond O, the second carbon's C double bond O breaks, this double bond or the pi bond breaks and forms O minus. This O minus picks up a proton from water or solvent molecule to form aldol, the product. Hope you understood the mechanism of aldol reaction. This is base catalyzed reaction or base catalyzed reactions mechanism. Thank you.